Hello, and a very warm welcome to the theIAShub. This is the Geography Optional Basic Series where we will be teaching you the basics of geography. So this is one such series where we wanted to give you the basics of geography in a clear-cut manner in a simplified language, right? If you have attended the previous sessions, you would already know that we are dealing with the fundamentals of the earth formations, and then we went into the formations of various other landforms also. And today we'll be discussing in little more detail about the various kind of plates and their interactions among these plates, right? So last class में हमने ये discuss किया था that what are the different types of plates that are present and what are the different kinds of layers of the earth which are there and how these seismic waves are helping those layers. So today we'll go one step ahead and we'll try to give you a basic sense of plates, interaction of plates कैसे होगा and what are the different types of plates, or is it an oceanic plate and continental plate, इनकी collision में क्या होगा, continental plates का collisions में क्या हो सकता है. A basic sense you need to have of understanding, right? So let us quickly get into the topics. So today we'll be learning about the different types of plates and about the interactions of plates. You know that the earth is composed of various plates, and these plates can be continent in nature and those plates also can be oceanic in nature. Continental plates are majorly dominated by continent and oceanic plates are majorly dominated by oceans. Now, to show you the different kinds of plates that are present, let me show you an image which gives you an understanding of the plates as well. What are the different types of plates? Firstly, you need to be aware of that. See here, just give me a minute. Okay, now broadly speaking, there are major plates and there are minor plates which are present on the earth, right? Now major plates का size बड़ा होता है, minor plates का size छोटा होता है, and each plates का interaction is something which we are going to study in detail today. So let me show you, there are some oceanic plates and there are some continental plates as well. So ये एक basic class है, तो I will not be going very detailed and depth into these topics. I'll give you a surface and little more understanding जहाँ पर आपको आगे topics समझ में आया. And if you do have any doubts, please post those doubts into the comment section. I'll be addressing those doubts as well. Right, come back. Here you can see a big plate. Okay, let me show you a different image. Now here you can see a big plate in the name of Pacific plate. And most of the Pacific plate, you see, it is present in the ocean and it is the largest plate which is present on the earth. Now this plate, which is deep into the lithosphere and it is broken from various angles. Now this is called as an oceanic plate. You see, there is a continental plate called South America. Now we call this South America as a continental plate, but in reality, if you check, there is also a continent and there is also an ocean here. Now why do we call this as a continent plate? It is because major portions of this plate are dominated by the continent. So, and it is named after this continent, that's why it is called as continental plate. But on the other side, if you see, there are interactions with respect to the plates of ocean also. Okay? Now there can be a plate which can have oceanic layer also, it can also have the continental layer, but oceanic layer agar dominant hai, we call it as oceanic plate, continental layer dominant hai, then we call it as continental plate. Come back, like that you have major plates such as Pacific plate is a major plate, South American plate is a major plate, Arabian plate is a major plate, Eurasian plate is a major plate, and then Indian plate is a major plate. Now these plates, they interact among each other. Now these interaction can be studied as convergence when two plates collide with each other. Imagine this is your plate and these plates, if they are colliding with each other, it is called as convergent plates or convergent boundary. Now these two plates can also diverge. They can move apart. That means this is called as divergent boundary. Right? Now two plates can also slide past against each other. This can move in this direction and this can move in this direction. Now this is called as, the boundary between them is called as transform boundary. Right? Now broadly speaking, there can be convergent boundaries, there can be divergent boundaries, and there can be transform boundaries. Right? And coming to the reasons why these plates move. The movement of the plates is primarily because of the mantle convectional cells. Now what is this mantle convectional cells? See, within the interior of the earth, deep within the interior of the earth, there is continuous movement of magmatic material because of the convectional cells. Now what are these convectional cells? Imagine this is your inner core, and here this is your surface of the earth. Here you have various different kinds of landforms. This can be a plain, this can be a plateau, again there can be a depression. In this way you can have multiple kind of landforms on the surface of the earth, right? And broadly speaking, here each landform has its own, just a minute. See, now these entire earth can be broken into pieces. Imagine this can be a piece, this can be a piece, this can be a piece. Like that, your earth can be broken into plates, and these pieces are nothing but plates, right? Now this is plate 1, 2, 3, 4, 5, 6, 7, 8. Now the movement of the plates is primarily because there is rise of mantle convectional cells, rise of magma, and the magma, as and when it cools down, it starts to diverge. Now whenever it starts to diverge, it is also creating a friction. What is that friction? Friction between what? It is a friction which you get to see in a divergent boundary or a convergent boundary, wherever the friction between different layers of the earth. Last class we have studied that there is crust, right? Beneath the crust you'll have mantle, beneath the mantle you have core. Core has inner core, outer core. Crust has the continental crust and oceanic crust. Imagine if this is ocean, this is your oceanic crust and this is your continental crust, and I have told you that continental crust is made up of the granitic material, oceanic crust is made up of basaltic material, right? This is what we have broadly discussed in the last class, right? Now come back, there is a rise of magma that is taking place, and this rise of magma, as and when it cools down, it starts to diverge. Now at the divergent plate, it is the magma, when it starts to diverge, it also drags along an upper layer which is nothing but lithosphere. ठीक है, ये है आपका lithosphere. This lithosphere will also move apart, right? Now any magma, if it is diverging, it also has to converge at one or the other point. Imagine here within the deep interior of the earth, a layer called mantle. In that and the outer core, the radioactive material is extremely present. See, radioactive materials, whenever their temperatures are high or their material concentration is high, they will start to rise their temperature. Now slowly you will get to see the rise of magma, and then it starts to diverge. So here the convergence of plates and divergence of plates is primarily because of the rise of the mantle convectional cells and the formation of these cells, the magma within the interior of the earth. In the last class also I have shown you a graphical representation, right? I'll come back to your doubt. Wait for 2 minutes. I know what your doubt is. You have been pointing out. Yes? Okay. Your doubt will be addressed in the next 5 to 10 minutes itself. Don't be worried. Right? Now come back. So like this, imagine there are multiple plates on the surface of the earth, and each plate will either converge or it will diverge or it will be moving, slide past against each other. In this, there are some kind of landforms that are formed. There are some kind of volcanic material that you get to see. We will try to understand the interactions of these plates. Now firstly, I've told you that you have an oceanic plate and you have a continental plate, right? You know the thickness. Which thickness is higher? Is it continental plate or oceanic plate? It is continental plate thickness is more. I'm talking about thickness, but density is less. Oceanic plate density is higher as compared to continental plate, but thickness less. See, I know a student has asked me here, sir, if the thickness is more, why is that it is so weak? It's not like that. See, you take a 100 sheet of papers, okay, stack up those papers like this. Imagine you have a paper, right? Like that, stack 100 papers above. The thickness of this paper will be more, right? But if I have this metal, the metal, though its thickness is less, but it is denser, right? It is more denser. Now the thickness of the density of this paper is less. So if both of them collide, which will be damaged or which will sink? The heavier density material will always sink. Now just imagine, though the thickness of this mobile phone is less, but its density is high, because of which it is considered to be sinking plate. Like that, this is like your oceanic plate. Oceanic plate ka density, last class we have decided that the density of the oceanic plate is the density of the oceanic plate is high and the density of the continental plate is less, but the thickness of the oceanic plate is very, very less. What is the thickness? The thickness is hardly 5 kilometers. The thickness jo hai na, ye jo thickness hai, it is hardly, on an average, it is 5 kilometers. The thickness of the continent is near about 30 to 70 kilometers deep inside. Now when these two plates collide with each other, it is actually the oceanic plate which will be sinking, but not the continental plate. We will take a case study and we'll try to understand here in a detailed and a lucid manner. I will not be using any much of the technical language here. It is because I wanted to give you a basic understanding first, and then we'll be venturing into further classes. Come back. So you got to understand there is oceanic plate and continental plate. Here, these two plates can interact as, firstly, an oceanic plate and an oceanic plate. They can converge, they can diverge, or they can move in a transform direction, right? Like that, the interactions are of different ways. This is an oceanic plate. There can be oceanic plate and there can be continental plate, right? Now these two plates can converge, they can diverge, or they can transform, right? Now the other type of interaction that you can get to see is the interactions of the continent and continent, right? There can be a continent plate and there can be another continent plate, right? These two can converge, again there can be divergence and there can be transform movement of the plate. But the kind of landforms that you get to see in the interactions of the ocean-ocean and the interaction of the ocean continent, they are completely different. I know you asked me where are the trenches formed. Are the trenches formed in the continental-continental convergence, or oceanic-continental convergence, or oceanic-oceanic convergence, or oceanic-oceanic divergence, or continental-continental divergence? So trenches, they can be formed in the convergent boundaries. Okay. More specifically, you think that trenches are only formed whenever there is a continental plate and oceanic plate, they collide. It is not like that. There can be trenches formed in the oceanic-oceanic convergence also, right? Wait for some time and wait for the next class. You'll get the complete picture of the plate tectonics. Many students do have their confusions in these topics, so I'll be clearing it out in a detailed manner. Come back. So let us try to understand and study one of these interactions today. It is the oceanic and the continental interaction, as well as the continental and continental plate movement interactions, right? So let us quickly try to understand this. Let's take the first one as a continental-continental interaction, right? Continent-continent interactions, or the plate movements of the continent and continent. See, the thickness can go up to 30 to 70 kilometers here also. Here also 30 to 70 kilometers, it depends on what kind of landform it is, right? On the other side, let us also learn along with the simultaneously take up the oceanic plate and continental plate, the interactions. So oceanic plate thickness is 5 kilometers, density high as compared to the thickness 30 to 70 kilometers on an average, density it is less. So everyone knows that there are multiple plates. If you broadly look into the plate tectonics map, you can also look into your atlas. Go to any atlas, you will find this plate tectonics map. Now you see, let us popularly take the major plate, that is Indian plate and Chinese plate. How did the Himalayas formed? You believe that most of these landforms are formed because of the continent and continent collision, right? And it is true. But if you have studied the sea floor spreading, which I will be teaching in the other classes, now the sea floor spreading theory says that our sea floors are spreading, and also we also have another theory called continental drift theory. The continental drift theory tries to explain what are the different types of movements, or it is the first theory which tried to attempt to explain how the continents are moving from one place to another place. And the forces which it have tried to explain by Wegener, they were not true, but today the reasons behind that are different, but the continents are definitely moving, right? Now let us popularly take the example of India and Chinese plate and try to understand this as a case study. So if you see, broadly speaking, everyone knows that there is Indian plate and there is also a Chinese plate. If you look into the plate movement of India, it is like this. See, imagine ye apna Indian plate hai and this is your Eurasian plate. When there is interaction, this has led to the formations of mountains, right? And you got to see the various ranges of mountains. You go to Himalayas, in the Himalayas, you will find the ranges of mountains to be like this. From the north to south, you see, you will find Karakoram mountains, Ladakh, Zanskar. Then you have the Great Himalayas, then Pir Panjal, Doladar, and then you have Shivaliks, right? This is Karakoram, Ladakh, Zanskar, Great Himalayas. These are Lesser Himalayas and these are Shivaliks, right? You go to northern regions, you will, mountain regions, especially the Himalayan regions in the Jammu and Kashmir, you will find a series of mountain ranges like this. Now in this series of mountain ranges, you need to understand that ye jo mountain ranges hai na, they are formed with because of the interactions of the continental-continental collision. Now what is this continental-continental collision which had led to the formations of these? Now see, this is also called as Pir Panjal, this is also called as Doladar. Now broadly speaking, here Karakoram is considered to be Trans-Himalayas. Ladakh or Zanskar, this is called as Tethys Himalayas. And these are considered to be the Himalayas. Now what is this? The term, ye Trans Himalayas kya hai, Tethyan Himalayas, why Ladakh range or Zanskar range is called as Tethyan Himalayas, and more specifically the Himalayas, the major Himalayas, actual Himalayas are Greater Himalayas, Lesser Himalayas and Shivaliks. You need to understand the formation of these mountains, and optional mein you will study in very detail about this formation. Now how did they form? Few minutes before I have shown you this image, right? Ye jo image hai, it is nothing but the Indian plate which is moving towards the Eurasian plate, and in between you got to see the formations of the mountains. But it is not that simple the way it looks. In the geography, you need to know the interactions of this plate, how they are formed. See, between India and Tibet, there was once a big ocean which is called as Tethys Sea. ठीक है, there is a sea called Tethys Sea. ये हर किसी को पता है ये Tethys Sea क्या है, right? Now, if there is an ocean beneath, don't you think that there is an oceanic plate? Yes, there is an ocean plate beneath the continent and continent, but there is an oceanic plate. If you see, the thickness of India is little bigger, the plate thickness is little bigger or more thickness. The thickness of the oceanic floor is very less, only 5 kilometers. You look into the thickness of the Tibetan plate or the Eurasian plate, this is more bigger, right? So today we will try to understand these interactions. Firstly, before our continent, the continent of India got collided with the continent of the Eurasia, there was a sea, and the sea is also a minor plate at the then time period. ये कितने time पुराना था? 250 million years से पहले हुआ था ये सब, ठीक है? 60-70 years before are the time periods when our Himalayas have been formed, right? Now, you broadly look into the formations of Himalayas, they are ranging from 40, 50, 24, 17. These are the time periods of the Himalayan formations of various hills, right? Now come back, let us try to understand the formations of the Himalayas, and before that, let me quickly once show you the major landforms or major plates that you get to see. See, you broadly need to understand these plates. Once quickly look into these plates. We are currently discussing about the interaction of Indian plate with that of the Eurasian plate. ये जो plate है, which can go deep into 60 kilometers, and it is nothing but the lithosphere, right? Now, in this interaction, before there was a theory called continental drift theory, and the continental drift theory says that our India was once in the southern hemisphere, right? There used to be, the landforms of India was like this. See, today, this is your United States, more or less, this is a very big landmass, right? And our India was part of a landmass which is in the southern hemisphere, and this is your Angara land, this is your Gondwana land. Pretty much more or less everyone knows about this. काफी basic चीजें हैं. If not, in the next class I will explain you the continental drift theory as well, right? Come back. So you know that our Indian plate, which was earlier here, and in between you have Tethys Sea. Now this Tethys Sea is nothing but the Tethys Sea or the Tethys Sea plate. This is an oceanic plate. ये है आपका oceanic plate. ये जो ocean plate है, it is actually colliding with the continental plate. Now this is your continent, ये है ocean, and then you have a continent. It's like this. If I have to draw this, imagine this is your continent, right? And in between you have a small plate which is ocean, and then you have, let me erase this, you have the Tibetan plate, and this is your Tibetan plate, right? So now when was this? This was during the initial phases, even before the formation of Himalayas. Time period and all in the main classroom, not now, right? So see, here the Indian plate started to move and the Tibetan plate started to move. Why? It is because here you got to see the convergence. You go into the interior of the earth. In the interior of the earth, the positions are like this. Suppose ये है आपका core, and above the core, if this material or the mantle convectional cell, if it is moving in this direction, it comes and sinks. As it sinks, there is a big mantle convectional cell which has been formed, right? This is how there is a mantle convectional cell, because of which the Indian plate is also moving, and the Tibetan plate is also moving. They started to collide with each other, but in between you have a very, very big Tethys Sea, which is having on an average thickness of 5 kilometers, but you know that the thickness of the Tethys Sea sediments, or the thickness of the density of the Tethys Sea is very high because it's an oceanic plate. So when Tethys Sea and Tibetan plate, they collide with each other, which plate will sink? Is it Tethys Sea or is it the Tibetan plate? It is the Tethys plate. Look, ये जो Tethys plate है, it will, under the collisions, let us try to draw this, the interactions of these collisions. So this is your Indian plate, and then you have the Tethys Sea. When they started to collide with each other, and this is your Tibet, India. So in this due process, there are sediments that are being accreted here, and the Tethys plate started to sink into the mantle, and that Tethys plate will lead to the formations of volcanic activity on the Tibet. It's like this. You zoom it and see, beneath the continental crust or beneath the lithosphere, you get to see the mantle. What is this? This is all the mantle. Now once the Tibetan plate, once the Tethys plate started to sink, it will start to melt. Right? It will start to melt. When it is melting, will it sit silent? No. It will not sit silent. It will start to rise up. How is it rising up? It starts to rise up. While it rises, it tries to bring up the mantle convectional cell material or the mantle material onto the surface. This will lead to the formations of volcanoes. Right? What is this? Volcanic material. Now you might be surprised. Tibet के ऊपर volcanoes है? हाँ, एक time पे था, अभी तो नहीं है. ठीक है? But when was this time period? This was 50 to 70 million years ago I am talking about. Right? There were no Himalayan formations before that were taking place. But see, whenever the oceanic plate, until here, let us consider this as an oceanic plate. The density of the oceanic plate is higher, and there is a lot of sediments which are present in this ocean. These sediments, as it starts to move towards the Tibetan plate, the material accretion starts. Right? The sediment accretion. यहाँ पे क्या हो रहा है? Sediments of the Tethys Sea accreting. This is how the sediments of the Tethys Sea starts to accrete. When they start to accrete, here you will slowly start to see the rise of the material here. And little later, let us see the same thing after few millions of years. After few millions of years, here the Indian plate, and then you have completely India, and then you have Tibet. Now the size of the oceanic plate, it is shrinking down. In this due process, you got to see some volcanic material here, and you also got to see the rise of the ocean material onto the Tibetan plateau. Right? Did the Himalayas form at this point? No. अभी तक Himalayas starting में form ही नहीं हुआ था. It is actually the Tibetan plateau के ऊपर volcanic material start to accrete. And then the accretion of the oceanic sediment started to take place over a period of time when this plate, oceanic plate, completely sank down. So this is your ocean. ये है आपका oceanic plate. The oceanic plate is still getting melted here, and then the rise of the magma is continuously there. The volcanic materials are still there, but little later you will get to see that the same Indian plate is now starts to collide with the Tibet. ये है India, right? And this is Tibet. You got to see some volcanic material which is present there, and then the rise of the sediments which are there in the Tethys Sea, these rise of the sediments in the Tethys Sea, because there's so much of rise in the sediments here. What are the sediments? Oceanic deposits hai. Ye jo oceanic deposits hai na, they got deposited here, and this led to the rise of the volcanic material here, right? The rise of the volcanic material here has led to the formations of, it led to the formations of Tethys Sea sediments, Tethys Sea sediments mountains. Now what is this Tethys Sea rise in the sediment mountains? Can you name that mountain? I'll be waiting for around 10 to 15 seconds. If you know the name, please mention the name of these mountains. And you know that in the previous slide I've told you there is Karakoram, Ladakh, Zanskar, Greater Himalayas, Lesser Himalayas and Shivaliks. But out of all these Himalayas, what hills are, what mountains are these Tethys Sea sediments? What mountains are they? Is it Karakoram? Is it Ladakh? Is it Zanskar? Is it Greater Himalayas or Lesser Himalayas? What are they? Yes? So online, please mention if you are aware of it. Kya hai? Studied in your graduation? Did you study it in the graduation? Yes. So what are these sediments? What hills are they? Today, where are they present? See, these mountains are nothing but the Zanskar ranges. ठीक है? ये है Zanskar hills. Right? The Tethys sediment hills are nothing but the Zanskar Himalayas. Right? Come back. Now what? In the further time period, if you see, already now, first formation of volcanic material is there, but here you need to understand what about the oceanic plate which was present between the India and the Tibetan plate. What happened to that plate? The plate has already sank into the mantle, but it is not completely melted. Okay, it is not completely melted. Now, why is the rise of mountains still happening in the Himalayas? Or you might have heard that the height of the Mount Everest is continuously increasing. Why is it increasing? It is because of this oceanic plate, which is currently sinking continuously into the core. I know there are many doubts here, but let me redraw it in a different way, which will give you a better clarity. Look, imagine, ये है आपका अर्थ, ठीक है? On the earth you have India here and you have Tibet here, and between, I told you this is nothing but a sea. ये एक sea था. Sea का, earlier the size of the sea was bigger. It is the Tethys Sea. Its size got shrank because from one side India was moving, on the other side the Tibet was moving, and in between the oceanic plate it sank down. As and it sinks down, it will start to melt. Where is it melting? It is melting into the mantle. Now this material which got melted, they got up and they gave rise to the volcanic material. But see, as and when the oceanic plate, it starts to sink, completely sank here. Now this oceanic plate, the Tethys plate, which is no longer present in between India and Tibet, it is slowly moving to the core. It is melting to the core. Yesterday in the last class, we have studied about a concept called partial melting. Imagine, ये जो material है, it is partially melting. Means some amount of material is getting melted and little more amount of material is still not getting melted. So that's why whatever the material which is not melted, it will go down or it will sink. That is how it works. So imagine this is your core and this is your outer core. So where does this material go? It finally goes to the core. Maybe while it is traveling, it will get melted. some part of the material might get melted. Now see here, I told you the concept of partial melting. Imagine this is a big piece of rock or a size of large piece of rock as big as the size of India. Now it is sinking down. While it is sinking down, look here, imagine the temperature is 2000 degrees Celsius. Okay? Now let's try to take this and study. यहाँ पे this is a piece of rock, and you know what is rock? Rock is nothing but a collection of minerals. Rock के अंदर काफी सारा, और this plate के अंदर काफी सारा minerals हो सकता है. Indian plate देखो हजारों mineral है, but लेकिन you look, this is also as big as the size, big continents. Now this part of the rock can melt at 1500 degrees Celsius. This can melt at 2500 degrees Celsius. This can melt at 800, this can melt at 3500, and this can melt at 3000. So imagine the temperature here is only 2000 degrees Celsius. That means this piece of the rock, this piece of the rock, and maybe it can melt at 3500, and this can melt at 4200. That means these pieces of the rock, they do not melt. They will still sink down. So while it is sinking, it starts to sink down, and it will lead to the movement of the plate. Right? That is nothing but partial melting. ये जो plate है, it is still actively, the Tethys plate which is present, it is still actively moving down, and because of which India is continuously moving towards Tibet, and in between there are rise of the mountains. Now here, broadly speaking, you have different set of mountain chains. It is Karakoram, Ladakh, Zanskar, Greater Himalayas, Lesser Himalayas, and Shivaliks. I told you Karakoram and Ladakh, they are called as Trans-Himalayas. Why are they called as Trans-Himalayas? Why? It is because, imagine, come, in the little later stage, if you see, let me draw this in a different page. Now this is your Indian plate, ठीक है? ये आपका continent है, and this is now the Tibetan plate. Indian plate, it is sinking down. To be more specific, it is this. Right? They are colliding with each other. So in this due process of the collision, I told you already there is rise of mountains. What is this rise of mountains? They are because of the Tethys Sea sediments. Now what are these? Zanskar ranges. And above this, ये Tibet के ऊपर कुछ volcanic material which was already there. What is this volcanic material? Volcanic arcs. Tibetan volcanic arcs were already present. क्यों? क्योंकि sinking oceanic plate was there, and that led to the formations. But लेकिन वो जो oceanic plate है ना, it is no longer present near to this plate. इसीलिए volcanic activity has been vanished off. Right? The volcanic activity has completely gone. There is no volcanic activity on this particular area. But look here, from now on, this was your Indian plate, or this is your Indian plate. ये जो Indian plate है ना, it went under the Chinese plate, and then it is moving like this. While it is moving, this plate got deformed. Deformed means, earlier this plate, it's getting folded. It's like this. You see, any continent or any solid, if you start to press more, there will be compressions and there will be depressions. Anticline and synclines will start to form, and in this due process, the plate of India is getting deformed. Slowly, here the rise of the mountain started to take place. ठीक है? Deformation. It gets folded. Right? Now, where are the mountains of Zanskar present? Are they present on Indian plate? Are they present on Tibetan plate? Tibetan plate. Now, here you have Karakoram ranges, here you have Ladakh ranges. Where are they present? Are they present on India? They are present on Tibet. इसीलिए these mountains are called as Trans-Himalayas. Now if you look on to the Greater Himalayas, this is the Greater Himalayas. Why are they formed? It is because of the crustal deformation of India, right? And in the optional class, very detailed we will study, in little more detail we'll study. This is only for your basic understanding I'm trying to tell you, right? Now the next chain of mountains that are formed are your lesser Himalayas, जिनका height थोड़ा कम है, and then you have Shivaliks, right? This is Shivaliks. So ये है आपका काराकोरम, लद्दाख, ज़ांस्कर, Greater Himalayas, Lesser Himalayas, and Shivaliks. Right? Now this is how the formations of the mountains took place. Now as the mountain formation started, you have to understand this plate is experiencing more weight. ठीक है, ये check करो. Imagine, suppose if I have a plate, okay, imagine this is a plate. Now, if I put extreme weight onto this plate, so when I start to put some heavier weight onto this plate, okay, very big mountains I started to keep. What happens to the weight of the plate? Increases. So what happens to this plate is that it will start to make 4 deeps. What are these 4 deeps? It is like this. The plate will start to make a 4 deep. To be more specific, the plate will bend. This is how the plate bends. Now if there is a river which is there, right? Imagine this is just as an analogy itself. The rivers which are there on them. So these rivers, whatever the rivers, they'll start to flow in this direction. The sediments of these rivers will now fill the mountains. Now they are called as 4 deeps. ठीक है, ये है आपका 4 deeps. Like that, you have many 4 deeps. The formation of Shivaliks. Shivaliks कौन सा rocks है? Sedimentary rocks. ठीक है, initially when the Greater Himalayas and Lesser Himalayas are formed, there was a 4 deep. And these 4 deeps, they got folded to form Shivaliks. And to be more specific, this entire Himalayan chain के बाद, earlier there used to be a big depression. Suppose, imagine that on the plate of India, just a minute. See, you know that Karakoram, Ladakh, Zanskar, Greater Himalayas, these are the chain of mountains, right? Now there was a big depression which has formed here. Now try to look from the side angle. Side angle mein, when you see them, it's like this. You have, imagine that these are Greater Himalayas, these are Lesser Himalayas, and then you have Shivalik. There was a big 4 deep. There are most of the rivers are present, they are coming from the hills, right? Now this 4 deep today is filled with the plains. What are these plains? आपका उत्तर प्रदेश, ठीक है? ये है आपका उत्तर प्रदेश plains. The entire plain area of Uttar Pradesh today is a 4 deep which was filled with the sediments. This entire area, all the way, it got filled with the sediments from the rivers which are coming from the Himalayas. Right? This is how the formation of the Himalayas took place in a nutshell. But we will be studying in a very detailed manner in the further classes. I'll stop here. Abhi tak, do you have any doubts? Please message in the comment section if you do have any doubts. I'll be waiting to take up your doubts. Any doubts regarding these topics? Yes, Arpit Baghel, if you have a doubt, just post it in the comment section. People, any doubt? Okay. Let's wait for 10 to 15 more seconds. Okay, come back. So, in this process, the formation of the Himalayas do to take place. But Himalayas ka height काफी ज़्यादा है, right? Like that, if you look into the continental collisions across the world, there are many continental collisions. Have you ever heard of the Ural Mountains? Ural Mountains are present here. Earlier, there used to be a plate. This is your Eurasian plate, and here also you used to have a plate here. With these two collisions, there is a chain of mountains which have been formed, and they are called as Urals. Today, the height of the Ural Mountains is very small, not as tall as the height of Himalayas. Why? Why? ये भी continental collision है. इससे पहले there used to be a sea between them. Not today, but there was a sea between them too. But why is the height of these Urals lower? On the other side, you look into the mountains of Himalayas, their height is the tallest, and these are the tallest mountains in the world. It is because, देखो, the movement of the convectional cells जो है ना, the movement of the convectional cells are primarily because of some changes that you see in the interior of the earth. This is a plate, and this is a plate. Why are these plates moving? They are primarily moving because of the mantle convectional cells. Right? Now here, I told you this is the oceanic plate which was called as Tethys. Why is this Tethys sediments or Tethys plate present here? It is because it has sank down, and today it is still having its journey towards the outer core. It is still moving towards the outer core. जब तक ये outer core तक ना पहुंचेगा, तब तक हमारा हिमालयास का height बढ़ेगा. ठीक है? Now there is another concept called isostasy. I'll tell that little later. But the primary reason for the movement of the Indian plate or the collision of the Indian plate with the Tibetan plate is because earlier the Tethys sediment, the Tethys plate, whatever was there, it went into the mantle, melted. The unmelted part, which is partially not melted, it is still sinking down towards the core. So because of that, हमारा दोनों plates are moving. But you look into the plate of the Eurasian plate and the Russian plate. एक time पे ये आपका Eurasia है. This is the Europe part. In between them, there used to be a plate. There used to be a unmelted plate. ये जो unmelted plate है, it completely sank down and got melted, and this is absent. That means it has reached till the core, and then it got completely melted off in the case of Eurasia. And the Ural mountains which are formed there, their height is almost stationary. Right? That is why the mountains of Ural mountains are present in the Europe and Russia ka boundary pe. So these mountains height is little lower. Earlier their height also used to be taller, but rivers and all which are present on these mountains, they have washed away the slopes, they reduced their height, and tomorrow, maybe after few million years, our height of the Himalayas will also reduce. Why? The Tethys plate, which is still partially melted, it is reaching towards the core, and once it reaches the core, there won't be any kind of mantle convectional movements. Now again, let me show you the mantle convectional plate movements which I have shown you a couple of days before in the last class. To make it or to give it sense to you, let's try to imagine here. See, the major movement of the plates is primarily because of these kind of mantle convectional cells. Now why are these convectional cells formed? Kyuki, imagine if there is a rise in the magma material here, it is an indication that at this area you have high temperature as compared to this area. Now why do you have high temperature here? Any reason? Why do you have high temperature here? Why do you have this high temperature? Why it is rising from here? Why not from here? क्यों? क्योंकि यहाँ पे radioactive materials होता है, right? The concentration of the radioactive materials is more here, and the concentration of the radioactive materials is less here. Now this concentration can keep on changing. कभी इधर भी हो सकता है, कभी उधर भी हो सकता है, कभी इधर भी हो सकता है. It depends on that concentration. So imagine that there is a concentration of radioactive materials are more, and the magma will slowly start to rise. When it starts to rise, as and when it starts to rise up, it comes to the layers near to the asthenosphere. We have talked about the temperatures into the interior of the earth. As you go deep, the temperature increases. As you come up, temperature reduces. Now the same magma which is at the bottom, it will be having high temperature. ये cool down होने के बाद it will start to diverge. Look, there is a divergence of magma here. It is moving outward, and the plates above are getting separated. And this concept we are going to learn tomorrow, divergence of the plates. Now on the other side, there can also be plates colliding with each other. Now this is the case of India, right? In this collision, this is divergence. Now you look into the collisions also. In the collisions, whenever there is collision, you will understand that it can be a ocean-ocean collision, ocean-continent का collision हो सकता है, and continent-continent का भी. Look here, this is a divergent. Now whatever that rises, it has to move apart, diverge, and then sink again. Why is this sinking here? Why? Why is this plate sinking here? You have seen that this part of the plate, see, the magma has risen here. It started to move apart and then sinking. Now imagine, ये है आपका India and this is your Tibet. They are moving apart, or they are moving against each other. And earlier there used to be a oceanic plate in between. That means ये है आपका ocean, and this is your Indian plate, and this is your Tibetan plate. So as and when this plate starts to sink, ये जो sink होकर, why is it sinking? Because of this convectional cells, right? These convectional cells are the ones which are helping to sink. Now as the sinking starts, you see, you'll understand that the material which is there, oceanic plate, continental plate, it's going and melting into the mantle, and when it starts to melt, the magma will start to rise up, right? And why is this melting here? Why is this melting? क्योंकि temperature ज़्यादा है, and sometimes the melting point of this particular continent can be low. मतलब कम temperatures पे भी melt हो सकता है. क्यों? क्योंकि इस plate के अंदर कहीं ना कहीं पानी होता है. This has water molecules. ये जो water molecules है, what do they do? This water molecules will heat and they get pressure. Pressurized water molecules can make this plate melt easily. And the melting point of this continent will also be lowered and can get melted easily here. So that's why it starts to melt. It starts to melt and it will start to rise, this magma. Right? As and when it starts to rises, this is your Tibetan plate. Imagine, ye hai Tethys sediments. They went, they melted, and then it gave rise to a magma. Here you will get volcanic material. Right? This is how the formations of the volcanoes you will get to see. But broadly speaking, ye jo volcanic material hai, it is today no longer present on the Tibet. Why? Because the melting part of the ocean is no longer there. Or the oceanic plate, whatever it melted, there is nothing left there. That is how the formations of the Himalayas took place. It is a result of the collisions of the continent and continent, but in between you got to see the collisions of ocean and continent also. Now in the next class we'll be learning about the various kinds of landforms which are formed at the collisions of ocean and ocean. We have today learned about continent, and in this continent collision we have seen. Next class we'll see the divergence. Though aise plates bahar, if they are moving away from each other, what kind of landforms you will see, what kind of material you will get to see. Right? We'll stop here, and if you have any doubts, you can message me. This is my contact number. Soon the geography batch is going to begin. You can directly enroll into the geography batch. Right? Thank you, and see you guys in the next class.